Hello everyone. In this video, I will teach you how you can gracefully handle signals within a bash shell script. There are times when you write shell scripts and you want to cancel the shell scripts by delivering a signal to it, maybe by using kill command. So you say kill and the script, and you want the shell script to handle that particular cancellation by a signal in a more graceful manner. The reason why you want to do that could be maybe you had created some couple of temp files, let's say in a script, and you want to delete those temp files, or if you establish connections to database or sockets or any other resources and you want to gracefully close them even when a signal is delivered. How do you achieve this? Well, in Bone compatible shells, there's Bone shell and all the derivatives, all the POSIX compliant shells that include KSH, KSH93, PDKSH, and Bash and Z shell. Most of these shells have a built-in called trap. So using this built-in command called trap, you can register a signal handler in a shell script for handling variety of signals that are available on your Linux environment. So I'm going to demonstrate how to achieve this by a simple script here. So for now, I'm just going to write a small shell script. I'll call that simple loop. And in here, this is a bash script. So I'm just going to start off with a signature /bin/bash and write a small for loop. So I'm going to use for I in open curly brace 1.20. I want to make this loop count to 20. And yes, you can use the variety of syntax for loop in bash, especially. You can use this syntax, which is convenient, and that's what I'm using. But on the contrary, you can use for double parenthesis I equals 0, I less than 10, I plus plus a C style for loop, or you can also use the seq command if at all you want to. So all these options are available. So I'm going to just stick to a simple for loop syntax in bash here using the brace expansion. So I'll use for I in 1 to 20, and here I'm just going to print the name of the script. I also want to print the process ID of this script. So if you want to get the process ID of the currently running shell, you can also use this special variable or special parameter called $. I'm going to put this in square bracket. Just to make it look intuitive, and then use counting $. I'm going to use a sleep for 1 second. So this will run for 20 seconds by default. I'll save the script right now and let me exit this. If at all I want to make this script executable, I can use a chmod command. I can use chmod +x and simple loop.sh, the name of the script that I created in my Vim editor. And now to run this, I can just say /simple loop.sh. As you can see, this will take about 20 seconds to complete. But if at all I want to terminate it midway, I want to cancel it midway, I can just go to another terminal and I can use kill and the process ID. That's 1380. You can see the process ID is being printed. You can see it did not count until 20. At the 70th count, it got terminated. By the way, this message comes from the default disposition or the default signal handlers installed by the kernel for variety of signals for all the processes. So any command, if you try to kill it, you'll see a message called terminated if it's on the terminal, right? If it's on your shell. You'll also see killed if it's a kill signal, that's kill -9, or you'll see a Control C, that's cat C or a cat C. If you deliver an interrupt signal, that happens when you press Control C on your keyboard. You also get a hang up if at all you get a sig up signal. So different signals, you'll see different messages printed by the default handler provided by the kernel. So I'm going to handle this signal. For doing that, I can use simple loop.sh, and here, let me create a function. I'll call this function as cancel for now. Yes, you can define a function in a shell without that function keyword. Just cancel open close parenthesis will work, but this will make it more readable. So that's the reason I'm using that syntax sugar called function to say it's a shell function. And then in this place, let me just go to say echo cancel invoke. That's it. I'm going to close this. You'll see what happens. By default, when I delivered a signal, it terminated the program, right? It terminated the script, but this time it will not terminate. It will just print this message. You can just observe that. Now just define this function. To register this as a signal handler in your shell script, you can use the trap built-in. You can use trap and the name of the command, in this case, the function. This can be any command. You can pass a command, or you can just put the function name if you define a function, followed by for what signals you want this handler to be invoked. By default, let me just use for term. I can also use for maybe hop, that is hang up signal. So these are the signal names that you can use. Right? I'll show you how to find out or how to use the signal names. You can also use signal number if you know the number, like 15 and 1 and 2 and so on. But I'm just using name, which is more intuitive and more readable. So this is how you register a signal handler, by using trap function to be registered as signal handler, followed by the list of signals separated by spaces. And after this, just run this program. I run this script. Let's say simple loop.sh now. When I do a kill, and the process ID of the script is 13960. So I'll just pass this. You can see that it calls that cancel invoke. You can see a message called cancel invoke being printed, but it did not cancel the script, it did not exit the script, right? If all you want to exit the script on a signal delivery after calling your function, you might want to explicitly exit right here. Right? You might want to use exit. If you don't use exit, it's just going to be a signal handler that will replace a default handler, a default disposition provided by the Linux kernel, and this will be executed instead. And because this does not exit, it will continue back to the script, right? So if that is your use case, you don't have to use exit. But if at all you want to gracefully exit out from your shell script after performing some graceful cleanups in here, then you perform the cleanup and then you call exit command, right? You can say exit with your own custom exit code if you want, like what signal number you are exiting based on. All that can be embedded in here, just a number. So I'm just using exit. It'll say, but without any argument, it'll exit with exit code or exit status 0, right? So with this modification, run this one more time. When I try to terminate this particular process by using 14125, you can see that it exited, right? By default, the kill will deliver term signal or signal terminate, which is signal number 15 in most Unixes, including Linux. You can see the variety of signal numbers and their associated names that you can use within your shell script for the trap built-in. For that, you can use kill -L in your command prompt, right, in your shell prompt. So when I say kill -L, it lists all the signal numbers. See, signal number 1 is sig-up, signal number 2 is sigint, signal number 3 is sigquit, 4 is sig-ill, that is illegal instruction, sig-trap. There are a variety of signals and their associated numbers in here. Now, you can either use a number or you can use a name. When you're using name, you can use a full name like this, like sig-hub and sig-term. Sig-term is 15, which you will see in here, right? Sig-term, 15. But you can simply use the suffix alone without that prefix called sig. That is convenient. So you can simply use term and hub, for instance. Let me run this one more time and try with signal hang-up here. If I do a kill -hub this time, and the process ID 14252, you can see that it executes this function cancel, which prints this message cancel invoked, right? So this is one of the ways that you can handle signals in your shell script. The trap command can also understand a special form called exit. So if you want to know whether your script exited gracefully or whether it exited because of a signal, you can have two different functions. You can have one more. You can also say trap one more time and then say maybe, rather than calling it exit, I'll just say quit, and I'll create a function called quit here. And here I'll just say script exited gracefully. And call exit here. Actually, when you're using this, I don't think you need to call exit. You can leave it as this because that's called when the script is exiting, right? And in this place, you can just say cancelled invoked. I can say caught a signal. Caught a signal, cancelling. Just a message, okay? Doing nothing in here. So as you can see, in the script, as usual, I have a for loop. When the for loop completes, the script exits, right? It reaches to the end of script. When it reaches the end of script and there's nothing more to run, the script exits. And during this exit, this trap is caught. That's called exit trap. And in this case, we'll invoke this function called quit, which is what I've registered on script exiting. And you can see this message being printed. However, if at all I deliver a signal like using kill command, if I say kill minus 15 or kill minus 1 or minus up or kill minus int, any of these signals are delivered. For the term signal and the hang up signal, this particular function is registered and it will be invoked. And this will make you have an option to perform cleanups in here and then exit after that. So with this being done, let me just save the script, run it one more time. While the script is running, I can just go back here. I just use kill 14386. You can see it says caught a signal cancelling, but because I called exit command within my signal handler, that is the cancel, exit is triggered and it also prints a message script exited gracefully. Right? You get both of these functions being invoked. If you don't want to invoke that function, you need to use some if-else conditions in your exit handler, that is in your quit, to figure out whether it's exiting by a signal or normally. You can try it out as an exercise, but this is how you perform this activity. Now, if I run this script one more time, and if I just pass a hop signal, oh, I think I said kill minus hop and 14473. You can see this. There are some things you should note that you can handle almost all the signals except sick kill and sick stop. These two signals will, if you try to register your handler for these two signals, it will have no effect. For example, if I just modify the script now and try to handle the kill signal, I'll also add int, I'll also add kill, and I'll also add stop. These last two signals will have no effect. Basically, you cannot change the default disposition provided by the kernel for sick kill and sick stop. That means sick kill and sick stop, you cannot handle them, you cannot ignore them, you cannot mask them. It will be delivered to the target process and the the default handler provided by the kernel will be invoked. So there's no way to handle it on your own. So that's something you should know. That when you do a kill minus 9 normally on Linux, what it does is it delivers a sick kill signal to the target process, right? And that cannot be handled by the script. It's not only by the script. In any program, you cannot handle sick kill or sick stop on all Linux environments. Not just Linux, it's a general feature on all standard Unix environments. Okay. Let me just save this script again and run this one more time. And I can just do a kill. This time I'll do a kill minus 9 and provide this process ID 14624. You can see that it's killed. You can see the message from the default disposition is called, which means there's no way to trap this signal, right? You cannot trap the signal in your shell script or in any programs that you might write where you register your signal handler. So sick kill and sick stop both cannot be handled, but you can handle all other signals and the signal names that you can use. As I already indicated, you can always use kill minus L in your shell prompt to know the list of names that you can use. Either you can use the complete full name or you can only use the suffix name, which is either hop or int or quit or ill. You can use any of them, right? So this is how you can implement your own signal handlers in a shell script. Let me just skip this program just so that you know. It's very simple. Again, just as a last recap, you just use a trap built-in and the name of the function, or if you have your own custom script or custom command, you can put that command here. Basically, it's a command, right? It takes a command, and a function can be treated like a command. It's a kind of a shell command now, right? You can use a function or any command of your choice, followed by the list of signals that you want to handle, right? If at all you want to handle a scenario where the script is exiting as such, the exit part of your script, then you can use a special term called exit with trap. So this is how you can register your own custom signal handlers or trap signals within a shell script and manage them, right? To know more about this trap shell built in bash shell, you can actually use help trap. It provides a detailed help. You can say help trap pipeless. It shows you trap signals and other events, defines and activates handlers to be run when the shell receives signals or other conditions. You know that the trap implementation on bash especially can handle not just signals, but for various conditions. One condition I told you is script exiting, right? But the list of conditions you want to list what trap understands, you can also use trap -l, which is same as running kill -l. Shows list of signals. But I think if you use trap without any argument, oh, sorry, trap -p, is it? No, -p. Let me tell you what that -p is. Okay, it shows display the trap commands associated with the signal specification. If you say trap -p and provide a signal number, signal name, it'll tell you what is the command that will be invoked for that. This could be used in a shell script for debugging purposes, right? So that's how you can register a signal handler. So I hope you found this video useful. So if you really liked, or if you really like this video and you learned something, yeah, be sure to hit the like and do subscribe. Thank you very much.